Hi, viewers. So please, before watching this video, please subscribe it. Don't forget. Today's topic is de-Broglie hypothesis of matter waves. And one more topic is there, expression for the de-Broglie wavelength. So first let me explain the de-Broglie hypothesis of matter waves. See here, first point, according to de-Broglie, according to de-Broglie hypothesis, a moving particle is associated with a wave which is known as a de-Broglie wave. So what is he saying? Suppose moving particle, it is one particle and it is moving in this direction. So while we are looking this body, this particle, so it appear to us it is moving in straight direction. But according to him, according to de-Broglie, he assumes body is not, this particle is not moving straight in direction. It is moving in the form of waves like this. He treat motion of every body, not only a particle, motion of every body as a wave. So that body is traveling in this manner. That is, he think like this only. And next is, see here, next second point is the wavelength of matter wave is given by. So he derived one equation. So he said just now, what he said, a body which is a body or a particle which is moving in one direction or in circular motion or in any manner. So he treat them as like this, okay, in the form of wave. Body is not moving in this, in the like this, in the same line, in the straight line. Body always moves in the form of waves only. So that is why he said a particle is associated with wave. That is the meaning of this, okay. And the second one is, see here, second one, he derived one equation. So there is one derivation also. Next I will explain that derivation also. Now see, lambda is a de-Broglie wavelength. Lambda is equals to h by mv. And again this equation written as a h by p. Why? M is a mass, v is a velocity. Product of mass and velocity gives us momentum. So that is why that is the equation. And here the hypothesis. How many hypotheses are there? There are only 3 hypotheses. So what are those 3 hypotheses? Let me explain one by one. Waves and particles are only 2 modes through which energy is propagated in nature. Right? So for example, that let it is a substance which emits the energy in all directions. Right? And so emitting energy in all directions, that is either that emitted energy is passes either in the form of waves or in the form of particles, he is saying. Okay, only 2 modes, either wave mode or particle mode. Okay, so that is the meaning of first point. Once again, waves and particles are only 2 modes through which energy is propagated in nature. Energy is transmitted in nature. That is the meaning. Okay, one mode is wave mode, other one is particle mode. Okay, from the source, energy either transmitted in the form of wave or in the form of particles. Okay, next second point is what? The universe is composed of light, radiations and matters. Yes, if you observe in the night time or in the daytime also appears. So because of brightness we cannot see, we cannot find the stars in the universe. But in the night time, if you observe, so many stars appears. Right? At somewhere stars are gathered, and at somewhere stars are away from each other, like this. In this form we see. Okay, every star is a source of energy. Right? Every star is a source of energy. Right? And every star contains a matter. Every star contains a matter. So that is why source of energy means that which energy? Light energy. So universe is second point is universe is composed means it contains what? Light radiations and matter. Yes, matter means it contains a mass and as well as it contains light energy. Okay, so that is the meaning. Radiation, why do we have to use the word radiation? Because energy is transmitting through vacuum. Any energy which transmit through vacuum, that is simply we have to say radiation. We have light energy transmit through the vacuum, so that is why we have to say them as what? Radiations. Our next third point is what? See the third point. The nature loves symmetry. What is the meaning of nature loves symmetry? Nature loves symmetry means if the matter exists in the nature, waves also exist in the nature. Right? So they are same. They must be symmetrical means they must be same. Therefore, matter and waves must be symmetrical means same. Okay, nature loves symmetry means if the matter exists, waves also exist in the universe, right? So that is the meaning of third point. And next one more point I have added at the below. If the radiation can act as a wave at some time and at like a particle at other time. Suppose radiation is behaving here what? Wave nature, then here particle nature cannot be present. Where the particle nature present? It present, but some other time it present. At this time, wave nature cannot present. So this is the things. And the material particle should act like a so material particle should act like a particle sometime and like a wave at other time. Okay, so particles also they act as waves and as well as particles, which electrons, protons, neutrons. These are the fundamental particles, right? So and already we proved particles like electron they behaves as a wave in Germer and Davison diffraction experiment. There I explained about the diffraction. Okay, so there electron diffracted means diffraction occurs when wave nature present, then only diffraction occurs. Okay, so like this, so there I explained clearly. And next one is next topic is expression for the de-Broglie wavelength. Just now I explained here the lambda is equals to h by me or lambda is equals to h by p. How this equation has come? So let me explain this equation. And see here, first one, expression for the de-Broglie wavelength. Considering the Planck theory of radiation, only one of Planck's theory of radiation. Okay, Planck's theory of radiation, the energy of photon is given by, so that is everybody know Planck's he has his own equation, that is E is equals to h nu it is, you must read it as nu means frequency. Okay, and this E is equals to h nu also written as E is equals to hc by lambda, because see here one equation is there, c is equals to nu lambda, that is the relation between velocity, wavelength and frequency. But see here what you have, frequency only, so from this frequency can be written as c by lambda, right? C by lambda substitute in the place of nu, then we get hc by lambda. So that is E is equals to hc by lambda, it has come like this. Next, let it is equation 1. And the next equation, according to Einstein energy mass equation, sorry, Einstein Okay. According to Einstein energy mass equation. So there is one famous equation of Einstein, that is E is equals to mc square, where c is the speed of light in vacuum, and it is the equation. Now see equation 2 and 1 both are energies. So that means in equation from equation 1 and 2, left side terms are equal, then right side terms are also equal. When the one side terms are equal, then other side terms must be equal. So that is why this is and this is equated here. So from this here the c square c 1c gets cancelled. Then what you get? Then what do you get? We get 1c c cancel. Then what? M is equals to h by, sorry, mc is equals to, among the two c 1c cancel, mc is equals to h by lambda. From this lambda is equals to h by mc. So see, this is the equation. And the next see the mc can be written as the p. Why? Because the p is the momentum. Momentum formula is a product of product of mass and mass into velocity, right? Product of mass into velocity. So product of mass into velocity is written as momentum. So replace this mc with a p, then this is a final equation. Either this equation or this, both equation are correct. It is in terms of momentum, it is in terms of mass and speed of light. Okay, so thank you friend. So don't forget watching, don't forget subscribing this video. Thank you.